Hello viewers, good morning. Welcome to our channel Upper Public School Kalburgi, and I am Ajay Dutt with today's biology class. So in this class we are going to deal with the respiration, and in the previous class we have also studied about respiration, where we have studied about the different methods of breakdown of glucose. Then we also finished about the differences between respiration and breathing, then differences between aerobic and anaerobic respiration. In today's class, we are going to deal with the mechanism of breathing. In today's class, we are going to deal with the mechanism of breathing. So, before dealing with the mechanism of breathing, first let us understand what are the various parts involved in the mechanism of respiration in human beings. So, starting with the human respiratory, contents of human respiratory system we shall know now. So, human respiratory system. Human respiratory system consists of the various parts, like starting with nose, then nostril, then nasal cavity, followed by pharynx, followed by larynx, then trachea, then branches of trachea, that is bronchi, and branches of bronchi, that is bronchioles. Then at the edge of this bronchioles we are having alveoli, and the bronchi, bronchioles and alveoli are found in lungs. So these are the various structures or organs involved in human respiratory system, starting with the nose, then nostril, nasal cavity, pharynx, larynx, trachea, bronchi, bronchioles and alveoli. So these are the following components of human respiratory system. Before dealing with the mechanism of breathing in human beings, we shall understand about the contents in the respiratory system. So these are the components of human respiratory system. Starting with nose. What is nose? Nose is an external projection, triangular projection. So it is present in your head region, that is on the face. So what is the role of nose? So you already know that it is helping in sensing smell, as well as it has role in respiratory system. It has role in respiratory system. So that is about the nose. That is about the nose. It is a triangular which is found in the face, which is helping in which is working in two ways. One in sensing the smell, the other one helping in respiration, other one helping in respiration or breathing. Okay. So then second one is the nostril. So what is this nostril? Nostrils are the two openings present at the nose. So the opening of the nose are called as the nostrils. So you find two openings in the nose, they are called as the nostrils. Then after nostrils, when you look at this diagram, you find a space or a cavity here, and this space is called as the nasal cavity. This space is called as the nasal cavity. When you look at the digestive system, so there you find mouth, which is the anterior opening of your body, and inside mouth we are having buccal cavity or oral cavity. So as in a respiratory system we are having nasal cavity, we are having nasal cavity. So what does this nostril consist of? Nostril mainly consists of hair-like projections called as cilia. Hair-like projections called as cilia. What these cilia do? These help in entrapping the dust particles and unwanted materials entering the tract. So it is acting as a primary filters. It's acting as a primary filter, avoiding unwanted particles and like dust and all those things, and some pollen grains also are trapped by the hair-like projections like cilia present inside the nostrils. Then third comes the nasal cavity. I have already said you about the nasal cavity. So nasal cavity is lined by mucous membrane. It is lined by mucus. So what is the role of mucus? Mucus is acting in three ways. First, it is making the air humid. Second one, it is trapping the dust particles, and apart from trapping the dust particles and making air humid, it is also warming the air. It is also warming the air. So these are the three functions of the nasal cavity here. So these are the three functions of the mucus which is found in the lining of the nasal cavity. So we have finished about the nose, nostril and the nasal cavity. Then coming to the next part, that is pharynx. So pharynx is the common passage for both your food and air. So the common region of our food and air is known as the pharynx. So that is when you are suffering with nose block. During such situations, so even you breathe in the air through your mouth. So it is possible through this pharynx. Is that clear? Then after the pharynx, we are having the larynx. But before going to larynx, I would like to say you that there is one more structure. It is the tip of the windpipe. That is called as glottis. So glottis is the region or opening of the windpipe. So when you look at respiratory system and digestive system diagrams together, you find the separation of the windpipe and the food pipe, and at the opening of the windpipe we are having that region is called as glottis. And that glottis is covered by a flap-like structure called as epiglottis. Suppose this is the glottis. So here we are having a flap-like structure, and this flap-like structure is closing and opening. So this flap-like structure is called as epiglottis. So what is the role of this epiglottis? This epiglottis into the lungs. So it is the one which is directing your food to move to the stomach rather than going to the lungs. This is about the glottis and epiglottis. And after the glottis and epiglottis, we are having the larynx. So actually, larynx is the voice box, you say, or you can say it as a voice box, or in common words you say it as a sound box. So what role this larynx has in respiration? It has actually no role in respiration, but the larynx has two ligamentous structures, rod-like structures, and those ligamentous rod-like structures are called as vocal cords. So those are called as vocal cords. So when air enters into this larynx, the vocal cords vibrate. When these vocal cords vibrate, it creates a sound which is helping you in your speech. So this is the function of the larynx. It is having no role in breathing in mechanism. Just air is passing through this larynx, and when it is passing through the larynx, it is also creating some sound. Then after larynx, we are having the windpipe is called as trachea. And food pipe is called as esophagus. In our common vernacular languages, we call it by different names, but scientifically they are esophagus, which is the food pipe, and the trachea, which is the windpipe. So trachea is the windpipe. So trachea is extending till the lungs, but before it goes to lungs, we are having C-shaped or horseshoe-shaped cartilaginous rings. So what are these rings meant for? So these rings are actually meant for the providing support to the trachea. So they help avoiding the collapsing of the trachea. That is the main role of the C-shaped or horseshoe-shaped rings of the trachea. Then the trachea is going to split apart, or it is going to branch into two structures, and those two structures are entering into our lungs. And those two branches of trachea are called as trachea is going to split into two branches, and those branches are called as bronchi. So they are called as bronchi. So bronchi is a plural and bronchus is singular. So this is bronchi and the only one is bronchus. So these bronchi are going to once again branch into the lungs, and those branches of bronchi are called as bronchioles. They are called as the bronchioles, and these at the end or at the posterior terminal or at the terminal of the bronchioles, we are having balloon or sac-like structures, air sac-like structures. They are called as alveoli. They are called as alveoli or alveoli. You can call them as alveoli. So these alveoli are having intensive network of blood vessels which are helping in diffusing in the oxygen and diffusing out carbon dioxide, that is when the blood is flowing through them. So their exchange of gases takes place, and the respiratory pigment is hemoglobin, which is a protein present over the RBCs, and it is consisting of iron, and iron has tendency to trap the oxygen, whereas the carbon dioxide in the dissolved form, that is in the plasma. So regarding that, we are going to study in detail in the next concept, that is circulation. So let us not stress more on that, and we will continue with the respiratory system. So these two, that is bronchi, bronchioles, are opening into lungs. So what are these lungs? So these lungs are air sacs present in the thoracic cavity of our body. So they are present in the thoracic cavity. What do you mean by thoracic cavity? The region between the neck and the abdomen. The region between the neck and abdomen is called as thoracic cavity, and in this thoracic cavity only number of vital organs are located or situated into our body. Right. So now coming towards the lungs. So lungs is protected by bony covering. Okay, so hard bony covering, and those are called as the ribs or rib cage. They are called as the rib cage, and between the lungs and the rib cage we are having intercostal muscles. They are having specialized type of muscles which are called as intercostal muscles. So between the ribs, so in this diagram you can see that these are the half part of the ribs, which I just have mentioned it to show you. So this is the rib cage, and between the rib cage and the lungs we are having some specialized type of muscles called as intercostal muscles. Then what is this rib cage meant for? It is meant to protect the lungs, which are the air sacs of our body, where exchange of gases takes place. Now coming to the lungs. So lungs is covered with two membranes, and those membranes are called as pleural membranes. Those membranes are called as pleural membranes. So the outer pleural membrane is parietal pleura, and the inner membrane is called as visceral pleura. So there are two membranes. The outer one is parietal pleura, the inner one is visceral pleura. So between the parietal pleura and visceral pleura we are having a space, and that is called as pleural cavity, and that is called as it is called as pleural cavity. So this pleural cavity is filled with a fluid called as pleural fluid. So what is this fluid made up of? This fluid is usually made up of plasma and, I believe, okay, some amount of proteins, I believe. So it is about 10 to 20 ml. So in some rare situations of disorder, so you find the deposition of such fluids more and more in the pleural cavity, and that situation is called as pleural effusion. It is called as pleural effusion or effusion. Pleural effusion. So what is the role of this pleural fluid? So it is lubricating the lungs. That is, when they are contracting and relaxing, so there what is happening is they are just lubricating the lungs, the pleural fluid. So this is all about the lungs, and the left lung is comparatively small than the right lung because slightly the heart is tilted towards the left side. So in order to adjust the heart, so the left lung is slightly smaller when compared to the right lung. So below that we are having the muscles, and those muscles like the intercostal muscle it may be, and one more type of muscle which is separating the lungs, that is the diaphragm. That is the diaphragm. It is a dome shaped structure. It is a dome shaped structure. This is the diaphragm. This is the diaphragm. Nostril, nasal cavity, pharynx, common opening, larynx, vocal cord, voice box, then trachea, windpipe, then bronchi, the branches of trachea, then bronchioles, the branches of bronchi, then the alveoles or alveoles which are present, all these things, bronchi, bronchioles and the alveoles are present in the lungs. So this is about the different structures or the contents of the human respiratory system. Contents of the human respiratory system. Now, after knowing about the contents of the human respiratory system, let us now understand about the mechanism of breathing. Let us now understand about the mechanism of breathing. So mechanism of breathing involves two steps. One is inhalation or breathing in, or inspiration. Then the second event, that is exhalation or breathing out, or expiration. So these are the two important mechanisms or important processes taking place in the mechanism of breathing. So now let us understand. So what all things happen when we inhale air and when we exhale air. So before understanding the concept, first let us understand one of the concept related to physics, that is movement of air or wind. So movement of air or wind. So according to physics, so we have studied that the air always from the region of its higher pressure to the region of its lower pressure. So whenever air is having the higher pressure, it always has tendency to move towards the region of its lower pressure. So where the air is having the higher pressure, it always moves towards the region where the pressure is low. Is that clear? It is similar to the diffusion, that is movement of molecules from region of higher concentration to region of lower concentration. So air also tends to move from the region of its higher pressure to the region of its lower pressure. After knowing about so this is the rough diagram of your lungs. So where I am going to explain you the mechanism of breathing. So this is the trachea, these are the bronchi, and this is the lung. So the events taking place through inspiration. So before understanding inspiration, three words you need to understand. One is atmospheric pressure, then the second one is intrapulmonary pressure, and then intrapulmonary volume. So entire concept of breathing depends upon these three: pressure, intrapulmonary pressure, and intrapulmonary volume. So during inhalation, what happens? That is contraction of intercostal muscles, which I have shown in the last diagram, and diaphragm takes place. That is that is downward movement of the lungs. Downward movement of the diaphragm. So the diaphragm moves to downwards. That is downward movement of diaphragm. Contraction of intercostal muscles and diaphragm leads to increase in the volume. So increase in the volume. Which volume? Intrapulmonary volume. So when intrapulmonary volume increases, so due to increase in the volume, there is a decrease in intrapulmonary pressure. Increase in intrapulmonary volume. Inside the lungs becomes more. When the volume or when the capacity of lungs become more, so the air pressure inside the lungs is far less. It is far less. So increase or hike in intrapulmonary volume and drop in intrapulmonary pressure. So what happens? The atmospheric pressure is more compared to the intrapulmonary pressure. So what is happening? The air is rushing from the atmosphere to your lungs. So you are understanding the concept. So what is happening? The intercostal muscles and the diaphragm, they are contracting and diaphragm goes downwards. Due to this contraction of the intercostal muscles and the diaphragm, the intrapulmonary volume is increasing. With the increase in intrapulmonary volume, there is decrease in intrapulmonary pressure. So as we increase the space, the more less will be the pressure inside. Suppose I have already given you the example. So if there is a classroom, so where we can fit about 20 students. So the size of the classroom is nothing but the volume of the classroom. 20 students comfortably. But what happens when you add 40 students into it? So the volume remains the same, but the students entering into classroom are more. So there is creation of a pressure inside the classroom. So less the volume, more will be the pressure. So less space you have more complications inside, or you have more pressure inside. So that is the concept here. So when there is increase in volume, it will be decrease in pressure. So when intrapulmonary volume increases, what is happening is the intrapulmonary pressure drops. So due to the decreased intrapulmonary pressure when compared to the atmosphere, the air is entering into the lungs. So to be more accurate, so about 760 mmHg pressure will be there in the atmosphere. So if both, that is in lungs as well as the atmosphere pressure, millimeter mercury will be the pressure. So when this thing is happening, so what happens here? It becomes 759. So 1 mmHg, that is reduced pressure. So in order, when you compare this to 760 for 759, what is happening is there is a drop in pressure. Due to drop in pressure, the air will enter inside the lungs. So what is happening in the inspiration here? First, intercostal muscles and diaphragm contract. Due to this, there is downward movement of diaphragm, and due to this, the intrapulmonary volume increases. Due to increased intrapulmonary volume, there is a decrease or drop in intrapulmonary pressure, that is from 760 to 759. So because of drop of intrapulmonary pressure, the pressure outside is 760 mm. 760 mmHg is higher compared to 759. Only 1 mmHg, but that is also the difference. So because of the increased atmospheric pressure, decreased intrapulmonary pressure, air is moving from region of its higher pressure. I have already said it is the physical concept, right? So this is what is happening in inspiration. Then after knowing about the inspiration, now let us know about what all things are happening in expiration or breathing out or exhalation. So what events are taking place here in this? Let us understand now. So once again, when exhalation takes place, what are all the events taking place? First and foremost event taking place is relaxation of diaphragm and intercostal muscles. due to relaxation what is happening, the diaphragm is coming back to its normal position, is up, that is upward movement of diaphragm, that is upward movement of diaphragm, relaxation of the intercostal muscles and the upward movement of diaphragm. Due to this what is happening, so there is decrease in intrapulmonary volume. So now what is happening is the volume of the lungs gets reduced. When volume gets reduced, the pressure automatically increases. So due to the relaxation of diaphragm and intercostal muscles, the intrapulmonary volume reduces or decreases. Due to decrease in intrapulmonary volume, so what is happening, there will be increase in the air pressure inside the lungs, that is intrapulmonary pressure. So decrease in increase in intrapulmonary pressure. So this decreases, this will increase. So what is happening here now? So instead of 760 mmHg, that is mercury, so it is becoming, the pressure inside the lungs is now 761 mmHg. Now it is 761 mmHg. So what is happening? Now outside atmospheric pressure is 760 mmHg. So what is happening? Movement of wind or air from region of its higher pressure region to the region of its lower pressure. So what is happening? 7 compared to 760. Therefore, the air from the lungs will rush out to the atmosphere. It will rush out to the atmosphere. So this is what is happening in exhalation. I repeat this concept for you. So in exhalation, that is expiration, what is happening is the relaxation of intercostal muscles and diaphragm, that is diaphragm is coming back to its normal position, and due to the relaxation of this diaphragm and this intercostal muscles, what is happening, the intrapulmonary volume is reduced. When volume is reduced, pressure will be increased, and due to increased pressure, the air is rushing out from the lung. This is what is happening in expiration. Inspiration, opposite, expiration process is taking place. So after expiration also, some amount of oxygen is left out. So that is called as residual oxygen. It is called as residual oxygen. To check that there is continuous supply of oxygen, we are having little amount of oxygen left out in the lung. That is called as residual volume of oxygen. That is called as residual oxygen. So this is about inspiration and expiration. Now let us understand the differences between inspiration and expiration, that is breathing in and breathing out. So when we breathe in, so what is happening? The contraction of intercostal muscles and diaphragm takes place. Then in expiration what is happening? That is, we will make a note. It would be easy for us to know. Differences. Breathing in, that is inspiration or inhalation. Breathing out. So in breathing in, contraction of intercostal muscles. Breathing out, relaxation. First and foremost. Then the second one is downward movement of diaphragm. Upward movement increased volume. Which volume you already know? Pulmonary volume. Increased volume, decreased pressure. So here in relaxation, decreased volume, increased pressure. Then due to increased volume, decreased pressure, air enters into lungs. So due to decreased volume, increased air exits out of lungs. So these are the events taking place in breathing out, that is inspiration, or inhalation, that is breathing out, expiration, exhaling out the air. So this is about the difference between inspiration and expiration, that is both together is called as breathing mechanism. So apart from this, in today's class we are also dealing with the breathing not breathing mechanism. How do plants breathe, we need to know. So in plants there are in animals we are having a specific organ or a structure for carrying out the process of taking in air and letting out air, but it is not same in case of plants. So what is happening with the plants? So each and every part of the plant needs to take care of the sources, its own sources. So they cannot rely upon each other. So whole of heart, my kidney, my brain, everything depends upon my lungs for air, that is oxygen. But it is not same in case of plants. So plants have their own sources. Like for leaf, they have the stomatal apparatus. It is they are having the two kidney shaped structures, and those two kidney shaped structures are surrounded with the subsidiary cells. These are called as the guard cells. The kidney shape or bean shaped cells are called as guard cells. So between the guard cells we are having opening called as a stoma. Then surrounding we are having different cells called as subsidiary cells. So these are helping in the process of exchange of gases in leaf. What about the stem? In stem we are having lenticels, right? So the stem has a chain or a set of dead cells, and there we have node-like structures, and those are called as the lenticels, and these lenticels do provide space for exchange of gas. So you already know that some plants have the coating of suberin, which is impermeable to gases as well as water, but these lenticels do have the opening. So through this opening the exchange of gases takes place within the stem. Then coming to root. So in few plants or in few plants which are found in some saline soils, so like you know in Sundarbans, that is in West Bengal and all those regions, so where the river meets the sea, so that makes the Israel community, and in that Israel community mostly the water is saline water, that is hard water, and which makes the breathing which makes intake of air bit difficult for those plants, that is through roots, and they're having roots which are running parallel, that is they are running parallel to their stem, and at the tip of the root we are having a opening called as nematophores. So through this nematophores the exchange of gases takes place, and apart several group of epiphytes, so that parasitic plant, that is which are living on other plants, so they are also having like orchids, so they are usually found growing on the stem or branches of the different trees. So they are also going to exchange their gas directly from the atmosphere through the roots. So through root we are having the nematophores in some plants. Through stem it is by lenticels, and in leaf it is by the guard cells, that is the guard cell, the stoma and the subsidiary cell together make a stomatal apparatus. Through this, so exchange of gases takes place in the plants also. Now coming to respiration, so respiration is also occurring in the plants simultaneously with the photosynthesis process. The exchange of gas is very active, or it is taking place more and more during photosynthesis, but as and when the photosynthesis gets reduced, or rate of photosynthesis gets reduced, the respiration rate or the exchange of gases is far less compared to the during day, because the stomatal apparatus or the guard cells closed. Because of the closure of the guard cells, there is no exchange. That's why during photosynthesis only the exchange of gases is more, and after photosynthesis it is actually less. We can say it is very less, because some other sources like lenticels they may take, or they have it through nematophores or the root hair cells, or any other different types of cells over in the body. So this is what we have learned in today's class. Hope you all have understood the concepts. So you can just raise your question in the evening session. Thank you.